In this lesson, we're going to discuss some of the different symmetric algorithms that you may come across when working out in the field. Now, a symmetric algorithm is a method of encryption where the same key is used for both encryption and decryption of your data. Now, we're going to be covering a few of the most commonly used symmetric algorithms, including DES, triple DES, IDEA, AES, Blowfish, Twofish, and then Rivest Cipher, including RC4, RC5, and RC6. Now, first, we have DES. Now, DES, or the Data Encryption Standard, is written out as DES, and it uses a 64-bit key with 8 bits of that being used for parity. Therefore, DES really only has an effective key length of 56 bits, which is, as you probably guessed by now, not very powerful and not very secure against the challenge of modern computing power. Now, DES was heavily used all the way back in the 1970s, and it was used all the way up until the early 2000s. With DES, each message is going to be broken up into 64-bit blocks and then pushed through 16 rounds of transposition and substitution to create the final ciphertext. Now, because of DES's weakness and its key size, a modified version of it known as triple DES, which is written as 3DES, was also created. Now, in this version, we're actually going to use 3 different 56-bit keys. The input data is going to be subjected to encryption through the DES algorithm using the first key. Then, the resulting ciphertext will attempt to be decrypted using that same algorithm, but using the second key. Now, because this key doesn't actually decrypt the data, it just scrambles it up even further, and then we'll put it through the DES algorithm one more time using the third key and the encryption function. So, we're encrypting, decrypting, and encrypting using 3 different keys, which really effectively creates us an algorithm that has a 112-bit key that we're using here as we're going through the DES process 3 times, encrypting, decrypting, and encrypting again. Now, second, we have IDEA. Now, IDEA is spelled IDEA, and it stands for the International Data Encryption Algorithm. Now, IDEA is another symmetric block cipher, and this again uses 64-bit blocks as its input, and then uses that to encrypt the data. The key size for IDEA is 128 bits, which makes it harder to break than DES, but it's not as widely utilized as the more common one that we're going to talk about, known as AES, or the Advanced Encryption Standard. Now, IDEA is commonly known only because it was really used a lot inside the PGP, or Pretty Good Privacy suite of tools. Now, ultimately, DES and triple DES that we talked about earlier simply were found to not be strong enough, and so a big contest was held by the National Institute of Standards and Technologies to create a replacement. IDEA was one of the entrants into this contest, but ultimately they didn't win. The winner actually brings us to our third type, which is called AES, or the Advanced Encryption Standard. Now, the Advanced Encryption Standard was actually chosen as a replacement for DES and triple DES by the US government through the National Institute of Standards and Technology. Now, AES can be used with a 128-bit key, a 192-bit key, or a 256-bit key. AES is also known as the Rijndael algorithm, or Rijndael cipher, because that was the name of the creator who made AES. But most people will simply call it AES because it's a lot easier to say. You're going to find that AES is widely used and has become the de facto standard in encryption for symmetric key cryptography. In fact, it's the encryption standard that's being used by the federal government for any encryption of sensitive but unclassified information. The fourth type we have is known as Blowfish. Now, Blowfish is a block cipher that uses a 32-bit to 448-bit encryption key and can encrypt 64 bits of data at a time when it's going through and doing those blocks. Originally, this was developed as a replacement for DES, but it wasn't widely utilized. Now, the fifth one we have is another variant, which is known as Twofish. Twofish was developed to be able to provide us with 128-bit blocks in the encryption algorithm and uses a 128-bit, 192-bit, or 256-bit encryption key. Both Blowfish and Twofish were never patented, and they were released as open-source products that people could use. Sixth, and finally, we have another set of symmetric algorithms that we need to look at, known as the RC cipher suite. Now, the RC cipher suite was created by Ron Rivest, a cryptographer who's created 6 algorithms under the name RC, which stands for Rivest Cipher. RC1 was never published. RC2 was considered weak and was skipped over. RC3 was actually cracked before it was even released to the public. But with RC4, RC5, and RC6, these were all released and they're commonly used in our networks today. RC4 is considered to be a stream cipher, and it uses a variable key size from 40 bits all the way up to 2048 bits. RC4 is going to be used in both Secure Socket Layer, SSL, as well as the Wired Equivalent Privacy, or WEP, that's used heavily on the internet and on our wireless networks. Now, RC5 is a block cipher that uses key sizes up to 2048 bits. And finally, we have RC6, which is based on the RC5 cipher, but is a stronger and more advanced version of it, and it was originally entered into the contest as a replacement for DES, But ultimately, the Ringenel cipher, known as AES, was chosen as the winner. So remember, if you're being asked about any encryption algorithms, you should be able to identify it as a specific algorithm being symmetric or asymmetric, and whether it is a block or stream cipher. You do not need to memorize all of the different block sizes or key sizes. I just brought that up as a way for you to understand which ones are more or less secure than others. Now, as we went through this lesson, we talked about DES, triple DES, IDEA, AES, Blowfish, Twofish, RC4, RC5, and RC6. All of these are considered to be symmetric algorithms. Now, most of these are also considered to be block ciphers except RC4. RC4 is the only symmetric cipher we discussed that is considered to be a stream cipher, so keep this in mind as you're working with the encryption out in the real world too. Finally, when it comes to symmetric encryption ciphers, the one that is most commonly used is going to be the Advanced Encryption Standard, and it's also considered to be the strongest of the symmetric algorithms that we covered in this lesson.